This is our schematics for our model. This is a jar filled with water salt solution connected to two nails with copper wires connected to them, and it connects to a battery to a voltmeter. We used a battery because the reaction is not spontaneous, so we will need it to jumpstart the whole reaction.
So our materials is the battery cell with wire connecting to it and two nails and with salt water in the jar. We also have a copper wire and a voltmeter to measure the energy. So first we connect the wire to the nail and this wire to the nail too. And then connect to this wire. So the complication that we have with building this model is the wire and the voltmeter, and the overall connection was too weak, and the reaction was taking too long to react. The wire was too small and it wasn't cut properly, and the voltmeter before wasn't connected and works properly, so that's the complication we had. As you can see, the number is going down after a while because it's running out of reactant. It took longer because it's not spontaneous.
May 5, 2016, time 3 p.m. We are explaining the calculations for an electrolytic cell. Electrolyte cells redox reaction equation. 2 water plus sodium chloride plus zinc transforms into zinc chloride plus sodium plus hydrogen plus hydroxide. And these are the oxidizing numbers: +4, -4, +1, -1, 0, +2, -1, 0, +2, -4, +2. Half reactions. Hydrogen transforms into hydrogen plus 2E electrons, and Na plus E negative transforms into sodium. Zinc transforms to zinc plus 2E. This one loses electrons and this one gains, and this one loses. So yeah, reactivity series. Most reactive is zinc with 1.7, followed by hydrogen with 2.2, and the least reactive, sodium, with 0.9. Zinc and Na are spontaneous together because OA and RA have to be together in order for a reaction to occur. Zinc and hydrogen are not spontaneous because two of the same agents cannot go together. No reaction will occur because there needs to be one element that loses and one that gains electrons. Primary cell, a half reaction of a battery. 2 magnesium oxide plus water plus 2 electrons transforms into magnesium O3 plus 2 hydroxide. It is a reduction, it's an oxidizing agent. The next one is right here. Zinc 2 hydroxide transforms into zinc oxide H2O, which is water. Then 2 electrons will be added. Oxidization, reducing agent. The oxidization reaction of this primary cell donates its 2 electrons to the reaction. 2 water, sodium chloride plus zinc transforms into zinc chloride plus sodium plus 2 hydrogen plus 2 hydroxide. In order to jolt the reactants and to the starting reaction. This is because the reaction requires a catalyst due to the fact that it's a non-spontaneous reaction. May 30, 2016, chemistry lab, time 12 a.m. We are explaining the whole process of the electrolytic cells. The electrolytic cell process starts with the external power supply, which in our model is the battery. The battery acts as an electric pump. The electric energy is used to do work on the electrons to cause an electron transfer inside the electrolytic. When the voltage is applied to the cell, electrons flow from the negative terminal of the battery towards the cathode of the electrolytic cell and are then consumed or gained by the water molecules, which have the more positive reduction potential. The electrons that are transferred are then donated to the solution. The sodium, which is the cathode, collects around the 2 zinc nails, which are the anodes of the reaction. The direction of electrons in the reaction move from the anode to cathodes in the electrolytic cell. Once the reaction starts, bubbles will start to form around the zinc nails. During the time of the formation of the bubbles, the voltmeter numbers increase. After a while, the nails begin to rust, leaving residue in the salt water solution. This is also when the numbers on the voltmeter start to decrease due to the fact that the reactants are running out. Therefore, without any more reactants, the reaction will eventually die out, as it is not spontaneous reaction.